Hi everyone, welcome to the third class of current electricity. In this lesson, we will study drift velocity of electrons. You know, metals are conductors, they have free electrons in them. So when you take a conductor, free electrons are there. What these free electrons are doing? They are moving. Okay, if electrons move, we will get a current. So when you take a metal wire, you should get a shock. Why? Electrons are moving on the conductor. So there will be a current. You should get a shock. But reality, you will never get a shock. Why this is so? So we know electrons are free, metals contain free electrons. Electrons are moving, but they are moving in random direction. Why they move in random direction? An electron move through the crystal, through the conductor, they collide with an ion or atom of the conductor, then change the direction, they bounce. They go move some distance, again hitting on another ion, and again change direction. So they keep on changing direction. So electrons are moving randomly. In a conductor, there are millions of electrons. So when we take the average of these velocities, average velocity will be 0. Why these electrons are moving? It is because of temperature. As temperature increases, electrons gain kinetic energy. Say they are moving. These velocities are due to temperature, and it is called thermal velocities. So free electrons in a metal or a conductor are in random motion. This random motion is due to temperature. Why they change directions? Due to the collisions with the ions or atoms in the conductor. Since they move in random direction, the average velocity is 0. This velocity is called thermal velocities of the electrons. So average thermal velocity of the electron is 0. Now, what happens if we apply an electric field across the ends of the conductor? You connect the conductor to a battery, then what will happen? You know, due to this electric field, each electron will experience a force. Force on an electron, force due to electric field, you know, F is Q into E. So each electron will experience a force. Due to this force, each electrons get accelerated. Electrons are accelerating opposite to the field direction. Okay, so they acquire a velocity. The average velocities of all these electrons under the action of the electric field is called drift velocity of the electrons. So what is drift velocity of the electrons? Average velocity of the electrons under the action of the external field is called drift velocity. Now we will derive the equation for drift velocity. We will derive the equation for drift velocity. This drift velocity of electron is very small. Drift velocity of the electron is very small. Let us derive the equation for drift velocity. So today's topic, drift velocity of electrons. We are going to derive expression for drift velocity. So, electrons in a conductor are in random motion due to temperature. The velocity of electrons due to this temperature is known as thermal velocity. Okay, so average thermal velocity will be 0. Average thermal velocity of the electron is 0. If U1, U2, U3, etc. are thermal velocities of electrons, then average of all this U1 plus U2 plus U3 divided by total number of electrons, n by n equals 0. So average of this thermal velocity is 0. U1 plus U2 plus U3 plus etc. plus Un equals 0. So you are considering this conductor. Okay. Now you connect to a battery. Electric field due to the battery is E. So electric field direction is like this, positive to negative. Okay. If the conductor was not connected to the battery, electrons were in random motion. I'm drawing its path there. I'm drawing the path of the electron by this blue line in the absence of an electric field. See, like this. So first electron is starting from this point A. It moves through a distance. At the point B, it collides with the atoms and changes direction, reaches point C. There again undergoes collision with the ion and reaches the point D. There again undergoes collision, reaches the point E. So this is the path of an electron in the absence of an external field. Now, when we applied the field, what will happen? Each electrons get accelerated by the force due to the field. So suppose the electrons here, it is accelerated opposite to the field direction. Electrons will be accelerated opposite to the field direction. Electron move opposite to the electric field. So what will happen? These electrons will experience a force in this direction. Force on the electron is E into E, small e. E small e is charge of the electron. So all the electrons will experience a force towards the left side. So the path of the electron are shifted. So the electron is drifted through a small distance. So new path of the electrons I will draw here by the red line. See, that red line shows the path of the electron in the presence of an electric field. Blue line represents path of the electron before the battery was connected. So when battery is applied, the electron is accelerated towards left. So they move through a distance. That is why the red line is coming. This is drift of the electron. Okay, this I have drawn for one electron. So there are millions of electrons in a conductor. You know, average of all these velocities, velocity is called a drift velocity. Now, what is the force on each electron? F is minus E. This equation F is QE, you know. Charge of electron is E. Then what is the acceleration of each electron? F by M. So we can write minus E by M. So acceleration of each electron is minus E by M. So all the electrons will acquire same acceleration only. Charge M all constant for electrons. So electrons are accelerated towards the left side, opposite to the electric field. So their velocity will change. So what will be the velocity of first electron? It becomes V1 equals U1 plus A tau 1. What is this tau 1? Relaxation time. You know, electron is accelerated, then it will collide with the ions. So time between that two collisions, time between two successive collisions is known as relaxation time. What will be the velocity of the second electron? U2 plus A tau 2. You know, U1, U2 thermal velocities. So all the electrons are getting accelerated like this. V3. U3 plus A tau 3. Average of all these velocity is known as drift velocity. So we can write drift velocity Vd. You have to take the average of all these velocities. So U1 plus A tau 1 plus U2 plus A tau 2 plus U3 plus A tau 3 plus etc. divided by N. That is the average of all these velocities. Now Vd equals, you can combine all U1, U2, U3, etc. all U terms. So U1 plus U2 plus U3 plus etc. divided by N plus A into A is also common. Tau 1 plus tau 2 plus etc. plus tau N whole divided by N. Okay. And you know the average thermal velocity, the first term is 0. So we can write drift velocity Vd equals 0 plus A tau 1 plus tau 2 plus etc. plus tau N divided by N is A into tau. This tau is the average relaxation time. Tau 1 plus tau 2 plus tau 3 plus etc. plus tau N divided by N. This is average relaxation time. What is average relaxation time? Time between two successive collisions. Time interval whenever there is no collision, right? Time between two successive collisions is called relaxation time. Average time is the relaxation time. So what is relaxation time? Time between, average time between two successive collisions. So we got Vd equals A tau. A is the acceleration. And we know the equation for acceleration. What is that? Vd equals A is minus E by M minus E by M into tau. So this is the equation for the drift velocity. Vd is equal to minus E by M into tau. This is the equation for relaxation time, drift velocity. This drift velocity is very small. it is of the order of 10 raised to -3 meter per second. Very small. See, you know, when you switch on a light, what will happen? Light glows immediately. But drift velocity of the electron is very small. Electrons are moving very slowly. But why the light is glowing immediately? It is like this. You take a tube of water. If some water enters one end, the same amount of water leaves the other end. In the same way, when one electron drifts at one end, all the electrons are drifting. So other end electron also moves with the same speed, right? Or we can say electromagnetic impulses travel with the speed of light. So this is the equation for drift velocity. Vd equals minus E m by tau. Also, you know this relation, E is equal to minus V by L. This you learned from the electrostatic second chapter. Electric field is the negative gradient of potential. So we can put this value. Vd equals minus E into minus V by L tau m. So EV by ml into tau. So this is another equation for drift velocity in terms of potential difference. EV by ml into tau. Okay. Now we will define another quantity, mobility. Mobility we denote by the letter mu. Mobility mu. Mobility is defined as the drift velocity per unit electric field, magnitude of drift velocity per unit electric field. So mobility, magnitude of drift velocity per unit electric field is called mobility. What is mobility? Mobility is the magnitude of drift velocity per unit electric field. Mu equals, you know, Vd, E by m into tau, magnitude, minus I didn't take, magnitude by E. So what will be this mu? You can cancel this E and you get E tau by m. E tau by m. This is the equation for mobility. And you remember unit, SI unit of mobility is meter square per volt second. If you substitute the unit for charge of electron, relaxation time, mass, you will get this. So SI unit of mobility is meter square per volt second. Now we can relate this drift velocity to electric current. We can derive the relation between drift velocity and current. The relation between drift velocity and current. You take a conductor. Conductor length L, area of cross section A, connect it to a battery. You know, electrons are moving like this, drifting through the conductor. Okay. You know the equation for current, I equals Q by T. To find the charge, you need to know number of electrons in the conductor. we assume that let small n be the number of electrons per unit volume. It is also known as number density of electrons. Let n be the number of electrons per unit volume. Let n be the number of electrons per unit volume of the conductor. If you know the volume of the conductor, you can find out the total number of electrons. So what is equal? How will you find out total number of electrons in the conductor? In the conductor, how will you find out? Total number of electrons, capital N, is, you know, number of electrons per unit volume, small n, into the volume of the conductor. See, the conductor has area A, length L. So it is a cylinder. This conductor is in the form of cylinder. So what is the volume? Base area into height. So A into height is L. So this is the total number of electrons in the conductor. Now you can find out charge in the conductor. Charge. Q is equal to N into E. So N, A, L, E. This is the equation for charge in the conductor. Now you can find out current. I is equal to Q divided by T. T you can relate to the velocity. T is distance by velocity. But electrons move through a distance L in the conductor. L. Velocity is the drift velocity, Vd. So what will be the current? I is equal to Q is Na Le divided by what is time? L by Vd. So what you are getting? Na E Vd. So this is the current relation between current and drift velocity. I equals Na E Vd. Okay. What is N? Number density of electrons. Number density of electrons is number of electrons per unit volume. Now you can find out current density also. Current density. Current density will denote by J. J is I by A. So what we are getting? Ne A Vd by A. You get current density as NeVd. That D is subscript. This relation is very important. So I end the class now. Thank you for watching. We will meet you in the next class. Goodbye.